Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 27 at chapter 8. This chapter is about the conservation of energy. We can see in this model we have a box at 0. At position 1 it is stationary, and then the position y1 is x plus h. We choose this one as reference point. Now it reaches to the position 2, where the box falls down just contact with the spring. The v2 we don't know, but the position is x, right? y2 x. Finally, it reaches to it because it moved down and compressed the spring. So the spring is compressed, and finally this box becomes stationary v3, and the position is 0, and acceleration is 5g. And then we need to find spring's constant k. So in this one, we can solve these problems by the conservation of energy. So we can see at initial, the initial energy is initial kinetic energy plus initial potential energy, 0. Agree? And the final, look at the final, we can see the final energy includes the final kinetic energy, final potential energy. So final potential energy has the gravity potential energy, mg y3, and also the elastic potential energy, this part. Because the spring is compressed distance x, so we have the elastic potential energy 1/2 kx squared. And also we look at this final position, we find the force analysis. It has gravity and it also has the elastic force. Agree? So elastic force kx minus the gravity equals to mass times acceleration. Their acceleration is given, so we can write this equation. Now you can see we have these two equations. We can input the known quantities to solve it. First one, v1 is 0, v3 is 0, and y3 is 0. So this equation can be simplified. This one, right? And the next one, we can simplify the equation to get it as kx equal to 6 mg. Now you can see we have two equations, first one and the second one, to solve the k. Can you do that? Yes, super easy. Because we can see in this equation, in these two equations, the unknown quantities just x and k, and we have two unknown quantities, two equations, so we can solve the equation k. And then when we solve the equation k, we find the k is equals to this function. Thank you.